So my talk is about a quest, somewhat quixotic quest perhaps, to build a custom web audio music playback engine. And so I'll start by showing you a little demo, and then I'll move on into to explain the philosophical underpinnings of the project. The meat or the main part of the talk will actually be about how the engine works. And I'll finish up by just saying what my future intentions with this are and where I think it might lead. So I'll just start with the demo. And so this is a player that's deployed on an artist website directly. And at the first glance, it sort of looks like a standard media player, but you can change the playback speed or the playback rate on the fly. So you can grab the sound. Yeah. And so to summarize, this is a web player for music, and the key idea here is the arbitrary changes to the speed and direction of playback, and it's designed to be deployed as a custom engine for each artist. So, why did I make this? And at this point, I've been a music producer and a DJ for more than half of my life. I started producing music as a teenager, and I spent some years on a DJ circuit. And it was not long after that I got my hands on my first pair of real vinyl turntables that I realized just how much the format of the music influences both the process of creation and also the listening experience. And this becomes obvious if you follow the early works of electronic dance music pioneers in the 80s. And their music has this sort of loopy, spirally quality to it, which very often stems from the fact that they were using turntables and they grew up experiencing music through turntables. And the same thing is true for me. This was my first Walkman. I think I got it from when I was about 9 years old, and I spent thousands of hours with this thing. My favorite feature was that when the batteries would begin to die, the playback wouldn't stop, and you could still listen to the tape and playing back slower and slower and slower. And that really, at that age, it made me think about how the music was put together. I was mostly listening to really fast, ridiculous rave music, and I don't know how this music was made, but being able to hear it at a slower speed made me fall in love with the music itself. And I think this is something worth thinking about, because when you fast forward to today, the typical way we experience music is through one of these three streaming platforms. And in internet age, this is basically a boomer stack by now, and it's actually time to maybe move forward a little bit. And it has large downstream effects on how we experience music. And I don't want to spend too much time on this because I could do a separate presentation, but there's many articles have been written of the effect of the attention economy and streaming on music creators, especially in niche genres. So this is why I began to think about all these websites are basically just websites. So why can't you just create your own Spotify or your own SoundCloud as an artist, or maybe your own YouTube? And this is basically, you can use the same tools that they did. Most of it is all open source. So it might just be feasible. So I began to investigate how to do it. And the typical way to playback sound on the web is through the HTML5 audio element. And unfortunately for our purposes, which is really the change of playback speed, it doesn't quite cut it. And that's because of it does have this playback rate property which you can set, but the range is limited, and this limitation is more or less arbitrary. And the bigger problem is the lower bound, so you cannot really go lower than half the speed. And another thing is that there's a pitch preserving algorithm, a time stretching algorithm in place, because I think main use case was envisioned as listening to conference talk at slightly higher speeds if they're boring or so. And here I have to give kudos to the Firefox team because they actually implemented this flag, and and it does work in Firefox, but they're the only browser. So we cannot use that. So to move on, I had to use the WebAudio API, and the typical way to play back some kind of samples through the WebAudio API is through the audio buffer source node. And this is a pretty good API because it almost has everything that we need. So the playback speed range or the playback rate range is actually, negative infinity to infinity according to the spec. But in practice, you cannot have negative playback rates, and we need that to have this rewind effect when you sort of grab the record and you spin it back. But it's not really a problem because when you think about it, sort of negative playback rates are basically just a reverse buffer played forward. And the only thing you have to keep in mind is that the offset and the remainder are flipped over. So all you need to do is to schedule the same buffer ahead, but with the remainder set instead of the offset. And so this is good news, but it's unfortunately not as simple because we have long compositions. So typically, maybe a single buffer would be enough to store. I think it was designed to store 40 or 45 seconds of the sound, but maybe you could even store a typical radio length single in it, and you could adjust the playback rate as you wish. But it's not enough because some compositions are over an hour long, right? It's been done before, and there's even compositions that are 10,000 years long. So imagine trying to play that back, and that's why you need some kind of streaming technology. So I had a look at these, and I ended up using something like HLS. So HLS stands for HTTP live streaming, and it's basically just a playlist that contains chunked segments of audio. So you can define the duration of the segments. They can be maybe 5 seconds or 10 seconds long as you wish. But that brings quite unique scheduling challenges because normally it would be quite simple, right? You download a 10-second chunk, and then you have some time until you can download the next one and schedule it. And the interesting thing is sort of that coming from a standard web developer perspective, audio is a bit different. So for me, it really helped to think about audio as sort of making a plan and submitting it to the audio context, because you cannot just do it imperatively. Everything is running in real time, so you have to sort of schedule in advance and just submit the plan and hope that the audio context executes it properly. And that's the problem that we face, because when you have arbitrary changes to the playback speed, then notice what happens. For example, if you schedule a doubling of speed there, then you have to throw out your entire future schedule because there's just not enough time. The node's going to end, and you're going to end up with a gap. So you have to create new buffers with the right speed set and sort of reschedule the whole thing. And the audio buffer source nodes are sort of fire and forget. So you can schedule them to start, and you can stop them, but you cannot reschedule them. And that becomes sort of a problem because for a turntable-style playback, you want to keep things responsive. So you only have a few milliseconds to react, and you wouldn't have time to sort of refetch the segments and create new buffers and so forth. And this seemed like quite a big problem. And I have to give full credit to a friend of mine here, who was a video streaming engineer, and he suggested that maybe I should have a look at some video processing techniques because they use things like double buffering and triple buffering. So while one frame is still being rendered, the previous one is stored in another buffer, and that's the one that's actually rendered on screen. It turns out that you can use a similar approach for the audio buffer source nodes. So instead of making one, just make a bunch of them. And each single event that comes in that is an event that changes the playback speed of the playing node. Remember, we have to schedule things a bit ahead, so we're always affecting one node. And scheduling things ahead to play ahead. So you just make a bunch of them, and then you just rotate through them, and backfill as needed. Actually, what I ended up doing is sort of a triple, double buffer, and the whole thing is twice, because you need the reverse segments as well, right? Because at any point, you can just flip back. So at any point, you can just flip back and start playing backwards at the arbitrary speed. And it's one thing to finally have figured this out, and I had some kind of a working prototype implementation, but it just became a giant mess. And it was giving me so much anxiety to think about, is my code at fault? Then I tried to rewrite it, tried to add more unit tests, but maybe my tests are wrong, or maybe the browsers are buggy. Like, who knows? Who knows what's going to happen? So I didn't know what to do. And even at some point, I developed this sort of custom debug user interface, which was just like, it shows like the number of nodes as they're being fired, and just to try to make sense of things. But I started thinking about, okay, like a turntable is basically just a machine, and maybe your watch is also just a machine. So how can it be so complicated, or why is it so hard to do? And I began thinking about machines. Oh, I have to manage some state. Okay, maybe state machines, finite state machines, what is that? So I started Googling, and I found this really cool sort of boomer technology out there. It turns out that people were extremely smart already like 50, 60 years ago, and they have figured everything out. So you have state charts, and there's a formal system, there's papers that describe exactly how you can design sort of systems that you know what kind of state they're transitioning between, and there's like this whole set of things around it. And I ended up using a really cool JavaScript library called xstate, and I have to say that this was the most reliable part of the entire code base. Like, the least reliable part was my brain, but this so the state chart library was fantastic. And this is an actual state chart of just the scheduler part of the engine. And there's others as well. Of course, you have to fetch and buffer and whatnot. But it fits very nicely within this actor model of computation. So unfortunately, it's not all perfect. I was quite happy when I figured out that the implementation is possible. But a good test for any kind of project is to just throw a perfect looped sine wave into your processing pipeline and see what happens. And basically, at certain playback speeds, you will begin to hear little clicks with like small imperfections, and these happen at the edges of the segment, and it's probably due to some resampling issues, because changing the playback rate is basically just resampling the audio at a different sample rate. And but because of the segments are ending, it doesn't know what continues next, and it tries to interpolate some kind of frames there, but it's not going to be perfect. And in most cases, I think with music, I found that it doesn't sound too bad, but a perfect implementation would require something using an audio workload. And essentially, it's the same mechanism, but you're just picking samples and tracking the indices of the samples instead of the segment. So unfortunately, we don't have the audio workload support in Safari. And we also have to call out Apple on this a bit, because I think not many people know that all browsers on sort of iPhones, iOS devices are actually just Safari in disguise. So the engine is exactly the same, and they're not playing very nicely with web audio. So that's quite unfortunate. But to move on to the last part of the presentation, and where I think this will lead us, is basically, I want you to have a look at this slide. I actually lifted this slide from a keynote at ADC last year by Aurelius Prochaska, and I think it's very fascinating, because you can see that, so recorded music is just an era in this timeline, and before that we used to have music that had to be performed, or executed by the people who wanted to hear it. And I think we still have this mindset of static recordings, whereas there's no reason for it. We have computers, there's no reason that we're still sticking to this format of 3-minute singles and everything based on static recordings. And this is what I'm hoping to do. So actually the player is just part of a bigger engine called songsling.studio that I'm working on. And I'm also developing it for my own music. But yeah, I'm hoping to do something more interesting here. So you see, it's still the same kind of player, but the music is now composed from clips, and there are logical. So you have parts of the recordings like intro, outro, whatever. And watch what happens now in the bottom right corner. So it's just the player just received brand new segment of the music on the fly, and it still works exactly the same as it just continues playback. And that's essentially it's the same mechanism as a turntable, but it's potentially infinite, and it can react in real time to online feedback. So yeah, that's about all I have. Thank you very much for listening, and yeah, if I will post the slides on my blog, and you can also find me here on Twitter, whatever, wherever you need. Thank you very much. It's been interesting.
Thank you very much. Are there any questions? Do you have time for a few quick questions?
My question is actually so short, I didn't need the mic. Will you DJ for us tonight or one of these nights? It sounds really great.
I do have a USB stick with my record collection on it, or some of it. So.
No, it sounds fabulous.
Yeah, thank you very much. That's actually a very nice comment.
Any other questions?
So from what I heard from you, basically kind of sounds like you cannot really efficiently manipulate MP3s in the browser, so they won't glitch when you, like between fragments. Like you always have to, like at least now, you without audio workload, you will have those clicks and you will not go away from them.
Well, not really, because the audio buffer is also happening on a separate thread. So as long as the thread that's not blocking the scheduling, it should be fine.
Yeah, but those issues you mentioned with the sine wave that you tested with, you got those.
No, I really think they're just due to the playback rates being in kind of rounded up or down, and because it sounds fine at 1 or at playback at 1 or maybe 2 or sort of clean multiples, it sounds fine. But when you get to these quirky in-between values, then I think the resampler doesn't know what's continuing next, and the segments are just chopped up, and it doesn't know. I think there's a way to get around this, possibly by doing this complicated crossfading between the buffers, but yeah, I haven't got around to trying that yet. Thank you.
Okay, one last question over there.
Thank you very much. I'm here.
Oh, nice.
I might have lost the thread a little bit, so it seemed like just changing the playback rate kind of became one of the aims there. I might be wrong. What I'm wondering is how tricky do you think it would be to do the pitch shift or time stretching?
Well, the nice thing that it's the Web Audio API, so you can pipe it in. You pipe it into the graph. So
okay.
Of course you could have all kinds of effects. You get the EQ, filtering, and actually I use some filtering. So when you flip over, then the low pass filter kicks in and sort of ducks the high frequencies a little bit. But there's so much interesting stuff you can do. So. think it's quite exciting. And I hope audio workout support will arrive everywhere. Yeah. Thank you.
Okay, let's thank the speaker again.
Thank you.